My name is Winnie Auma Otieno. I work at Visca as the head of business development, and it's our pleasure to have you join. Thank you for accepting our invitation.
Hello guys, how are you? My name is Baraka Njagi. I'm an automation engineer, knowledge in PLCs, SCADA systems, pneumatics, drives, anything to do with automation. And today I'm actually privileged to be your facilitator for today. We will cover much, being an introductory course. We might not do much of practical work today, but I hope by the end of this session, everybody will have a grasp of all that there is to do with PLCs, because that is what you're starting with. And I'd like to invite you also, as we learn this, that you take this knowledge to the next level. Theoretical knowledge is important, but of more importance is how you can apply it to the field. So without much further ado, I would like us to start. This is an introduction course facilitated by Visca Capacity Limited. As Madam Winnie has introduced herself and the company, and I have also introduced myself. And this is all that we are going to learn today. We are going to discuss just a few basics, a couple of things that by the end of this session, you should be able to have. And the first of those things will be, what is a PLC? We'll also handle the different functions of a PLC, the components of a PLC, software structure. We'll do a bit of basic programming, the theoretical part of it. And we'll also find out how there is an industrial setup of automation and how it happens. I have written all the information there, so it will be much more of reading, but I'll explain as we go by. So imagine you are at home watching me, maybe on your computer, maybe on your phone, and your phone has components. As you can see, I've written there. You have a mouse, you have a keyboard, you have a touchpad, screen, motherboard, different kinds of ports, Ethernet, USB cables. You have a hard disk, you have a place where you can put your CD. So we can do all kinds of these things, all kinds of things with it. You can watch movies, you can play games, you can browse, you can make slides like the one we are watching right now. And all this is made possible using the components that I have named above. And if you take keen notice, I also want to introduce to you one of my favorite cars. Yeah, imagine driving this car that you see here, or your favorite car, for example. You can use it for your luxurious driving, but there are areas that you cannot drive. And the reason is because different cars require different terrains. So you might need a different car if you are to go to a mountainous region. You might need a different car if you are to go to a sandy region. You might need a different car if you are to go to a swampy region. All those cars, all those things are cars, but they are used for different locations and terrain. So in simple terms, what we are saying is a PLC is like a monster truck. Let me use that example. I have used it here. That can be driven on normal roads, yes, but operates best in a tough terrain. A PLC is a computer. That is the point I want you to note. That first of all, the PLC is a computer that has been structured to work in a terrain called an industry. So this course, I want you to understand that we are covering all specs of people, from people who do not have any idea of what a PLC is, to guys who have at least a bit of knowledge of what a PLC is. So don't mind the simple explanations. I want us all to have an understanding of what they are. So the engineering definition of a PLC, as I've written there, is that it's a rugged computer that forms the basics and the basis of industrial automation. So industrial automation simply cannot happen without PLCs. And the definition of PLC, as you can see there, all of us, most of us know it, programmable logic controller. So those are three words that I would like to describe what they mean. Programmable logic controller. First of all, think of an input. I want you to think of your basic bed switch. I want you to think of, in your bedroom, maybe there are two switches and there is one bulb. and you can turn on and off that bulb using either of those two switches. So that is actually a logic. A logic is a definition factor of whether something is high or low, whether something is 1 or 0, if I can put it in that, or if I can put it in basic terms, if a bulb is on or off. That is a logic. So a programmable logic controller is a system or a unit that can be able to manipulate different logics to come up with different solutions, to come up with different outputs. So for example, if I am to run a motor, if I am to run a conveyor, for example, I have my start button and my stop button. If I am to press start, then that the PLC should be able to determine that the logic is high. And if the logic is high, then it should actuate the motor that is driving the conveyor to be able to do it. So a programmable logic controller is simply a computer that can be able to exercise and execute logics that have been put in place by a programmer so that it can put sufficient outputs as required. So we'll go on to the different components of a PLC. There are 3 major components, just like in your home computer. And there is the hardware, the firmware, and the software. So all of this, we are going to go through them slowly by slowly so that you can have an understanding of the same. Let's look at the hardware configuration. So any PLC system, just like your basic computer, will contain the following. We'll have an input section, which in our case can be analog or digital or both. We have an output, which also can be analog, digital, or both. We have a memory, which can be volatile or non-volatile, or even both. Volatile memory is one that when power is cut off, the memory or the data in it is erased. And non-volatile memory retains its data even when the power is off. So we can have a memory. There is also a CPU, central processing unit, for anybody that does not understand that. We also have communication protocols. We also have a power supply module. We also have a racking system, and the basic is a programming device. So your programming device is what you use to put the program into the PLC. So this is just a block diagram showing the hardware configuration, as you can see. If you can see, we have a programming device, which in this case is your laptop or your computer. Then we have an input interface. There is a power supply. There is a processor, which is in the CPU. There is a communication device. There is where data is stored, your memory, and there is the output. So all this we'll discuss in detail in a few. We are just having an overview look of the same. So we go to the next one, which is the firmware. The firmware simply is a software, the software installed by the PLC manufacturer that provides low-level control to the PLC hardware. I can put it this way, that, for example, if you buy your laptop, there is a software that comes with it that you can install softwares on top of it. For example, you can say Ubuntu, we can say Windows, for those that use those. So that is a firmware. So the same case, a PLC has a firmware in it. And normally, it says that it cannot be changed. And the reason it cannot be changed is because in case it gets corrupted, the manufacturer has to go to configure it back again. And this happens normally when there is a sudden power failure. So one of the things that you have to watch out while you're working with PLCs is you have to ensure that your PLC is well protected, maybe a UPS or a power supply that can support power fluctuations. So all that you have to see that. So the software configuration, the software is a program that is, as I've written there, configured to control a specific task in the PLC. Normally, a PLC program can be done using 5 languages, and we will highlight them in a few. There are 5 of them, but they are grouped into 2. So the first one is a structured text, also known as STL. We have our instruction lists. Those are all from textual languages. Programming can be done using 5 major languages. There are others, but we will not highlight them today. And the first 2 is structured text and instruction lists. These are textual languages. And there are also graphical languages, which most of you are now familiar with: ladder diagrams, functional block diagrams, and sequential function charts. So from the next slides, we'll be highlighting what each and every one of these is and how they work. We might not get into much detail about them and the programming bit, but I'll show you how they look like and how they operate. So this is a typical example of a statement list. So a statement list is a textual program that can be used to create the code section of logic blocks. So if you can remember, maybe for those who did programming, it's a language that is determined by statements. So for example, as you can see in my screen, that if this analog data is needed to actuate an output, the statement itself is written that analog data actuate input 4150.2 alarm external bit. If that device fails, then do this. So that is a structured, is a statement list. Its syntax is similar to the assembly language and consists of instructions followed by addresses of which the instructions can act. So think of it like a train. If somebody presses stop in the train, then if you are to do the programming, you have to actually write the name stop the train. So think of it that way. So that is a statement list. The next one is an instruction list. So an instruction list is considered also a low-level language, and this one uses binary language. And each instruction, as I have written there, is placed on a new line. So as compared to the first one, you can see that these ones have special instructions for each item. So for example, in our picture there, A is standing for stop and another A for block. So they are put in such a way that all these things can be able to be executed directly by the computer CPU without having to be converted. So they are machine language. So the first 2, all of them are machine language. As you look at the next one, function block, I'm sure most of you have been able to see this. This is a graphical language. The other one were textual. They are blocks. In our example here, we have 2 timers, timer 1 and timer 2. And as you can see there is an input called T2.Q. There is a time given, the present time, 2 seconds, expected time, the output, all going to another block. And after all that has done, the system, or rather maybe the LED blinks. So this is a functional block diagram. They are in blocks. And compared to the others, as we shall see, these ones are graphical. We can see the flow of process from one station to another. We can see how it is flowing all the way down from the start. If you look at all this, you will see that there are instructions given to blocks and the blocks actuates an output. I hope all of us can be able to see. Then there is what we call the sequential flowchart. And typically to your flowchart that you used in prior education, it is a step from step 1 all the way down, meaning step 3 cannot be done unless step 1 and 2 have been actualized. These charts break down sequential tasks down into steps. So if you were to do something to move from point A to point D, then point B and C have to be actuated before point D has arrived. So as I have written down there, convention states that the flow through an SFC is from top to bottom, unless indicated by an arrow. You have drawn your flowcharts in prior education, so it's just the same principle. And then we have the ones that are most commonly used, which we call ladder diagrams. Another name for that, ladder logic. And the reason they are called ladders is, as you can see, the programming makes it look like a series of ladders that you can climb up and down from one network to the other. By default, the programming is done from the first to the last. So if it is this diagram that we are seeing here, push button I0.0, this first network has to be actuated before the second network is actuated, before the third and the fourth and the fifth. But you will notice that the PLC is very fast, that a human eye cannot necessarily see which one is not being actuated. So those are the 5 basic programming languages that are used. There are others that we cannot cover right now. There is an example called CFC, which is a continuous function chart, but those ones we will not handle them in this case. So just a recap, we have 5 languages grouped into 2. Number 1, textual languages, which are structured texts and instruction lists. Number 2, graphical languages, which can be grouped into ladder diagram, function block, and sequential function chart. In case any question arises, please feel free to write it down on the comment section, and I'll be able to see it. So now we go to our PLC manufacturers. I'm sure you have seen different kinds of PLCs. What I have done is I have listed the PLC manufacturers and the software that they manufacture. So for example, you'll find a PLC called ABB, and the software that is used to program that ABB PLC is called an automation builder. You'll find another one called Allen Bradley that is programmed using RS Logic all the way down. Siemens, they use Semantic Manager. There are other softwares. These ones are the main software. Does not mean that there are no other softwares. They are the main software that I've listed here. So for example, in Siemens, as we look at, as we end, there are various softwares that can be used. In Honeywell PLCs, there is Master Logic. In Mitsubishi, there is GXWorks. In Yokogawa PLCs, there is FAM3. Toshiba has V2000. General Electric has what we call CI Implicity. Omron has CX1. Schneider has Twido Suite. Modicon has Control Experts. These are not the only PLCs that are there. There are many other PLCs, but these ones are just the main ones that you can find in industry. Of all these, I have not listed them in any merit. So you can find any of these in the modern industries that we have right now. So having said that, we can now look at the different kinds and the different types of PLCs, and they are grouped into 3. I'm sure you have heard of the first 2. The first one is the compact PLCs. We also have modular PLCs and soft PLCs. Soft PLCs is actually a new technology that is coming up, and we shall be able to discuss much more of it as we are going on. So let's look at it, each and every one of it. So the first one, as we have said, is compact PLCs. And this is an example of how they look like. As you can see, they have a monolithic construction. By monolithic, I mean everything is in one compact. So they have the inputs in there, they have the outputs in there, they have the CPU in there, they have the communication protocol in there, everything is there. As you can see, what I've written there is that there is one processor for it. And the most common communication module is field bus. That is what you'll find in most compact PLCs. We'll look at communication a while later. The next one is the modular PLCs. And these are the kinds that are grouped into structures. So for example, in our diagram here, you can see they are modular. They have a CPU here. They have a communication protocol. They have an input, an output, digital input, digital output, all those things. So it says here that they have one or multiple processor systems. So that can be actuated by the fact that they are modular. And communication between one module and the next is actually achieved because they have a backplane. A backplane can enable them to connect and communicate between each other. Then there is this, what we call soft PLCs. Probably most of you haven't heard of it, but they are advanced systems that build up machines such as industrial computers. And what happens is instead of the physical compact or modular PLCs, It is a software or a system that has been designed to make sure that any input that it receives. So imagine your computer and where you put your mouse. Imagine your computer and where you put maybe your flash drive. All those are ports for inputs and outputs. So soft PLCs is just like one system which can be built up to perform like a PLC. The advantage of this is that they are very fast and they can be used to do much more complex systems than others. A good example is the basic distributed control system. The DCSs are just the basics of the soft PLCs. We might not look at this in detail, but these are what is there right now in the trending markets. As you can see, I have said there that they have a direct use of CPU with embedded systems and programs such as Windows NT. So what happens is a manufacturer wanting to do a program for their PLCs, what they will do is they will approach a company like Windows and tell them to specify and to do a specific system or Windows firmware for their PLC so that now it can be unique. So that is what we call soft PLCs. So as we go on, I'm sure most of you know that there are various applications of PLCs. These are not the only ones. These are just a few. I'll give you an assignment that you can go and research more on where PLCs can be applied. But to list a few, there is the mining industry, there is the petroleum and gas industry, there is the food and beverage industry, there is the vehicle assembly, material handling industries. There are also robotics, as you can see. So there are different kinds. All these are different kinds of application areas for our PLCs. This is the vehicle industry, as you can see, being assembled. We also have the mining industry, the oil and gas industry. Yeah, we have the food and beverage industry. Yeah, material handling industry. All this, as you can see, is also for those who love food. That is your kind of industry right there. And so I would like us to take a break for a few minutes as I read through your questions and answer if there be any. So back to you, Madam Winnie.
Okay, thank you, Baraka. Hello, everyone. I'm hoping you can hear us. I would like us to take just a moment of reflection, but I haven't seen any questions on the chat, Baraka, and I presume that guys are just picking up. So probably we can just proceed into the next topic so that as any questions emerge, we can rope you in. Okay, I think somebody has asked, so a question there on the chat, Baraka, I think you can see it. He's talking of, so a specific manufacturer will have a PLC with a combination of different languages or a specific one?
So I'll tell you for a fact that it varies from different manufacturers to others. So I'll give you an example. With Siemens, they use actually all the 5 programming languages. With something like Omron, they just use 1 programming language. It depends with the kind of manufacturer, the specific manufacturer that you want. How Siemens have put their PLCs to be is that as you're doing programming, you can easily change and shift from one language to the other. So I would like you to know that it does not depend on the manufacturer to know which PLC language you'll use. What happens is a different manufacturer will use a different kind of PLC language. I hope I've answered you. Another question here I have from Stephen Gitahi. Hi, with regards to Industry 4.0 comes about the introduction of Internet of Things. Kindly comment on how PLCs are adapting to these changes in the industry. Okay, so I'd like you to know, first of all, that as we are doing this introductory course, this is just like a pin in the midst of many pins, let's say 1 million pins, whatever we are doing right now. And as we advance in these trainings, you'll come to realize that there are many other things that happen in PLC programming. So for example, the next step after learning how to program a PLC, what happens is you connect it to maybe a SCADA system. Let's put it that way. Once you've connected it to a SCADA system, the SCADA system, you can be able now to connect it to the internet. So there are different variations and things that you can be able to connect and view from the internet. So from the internet now, even as you're seated in your house, you can be able to control a whole system as you're seated from the comfort of your home. So the PLC right now, what is happening is they are changing their communication protocols. Most of them that were serial are now coming up with brands and are now coming up with systems and PLCs that can be able to connect easily to the Ethernet. Siemens, for example, now have a wireless communication protocol that can be able to communicate wirelessly. Also, Omron are coming up with their own PLC signal communication protocol that can be able to remotely connect different machines without the use of cables. So as you can see, as Industrial 4.0 is coming up and the Internet of Things, this is just a basic knowledge that we are trying to get right now. But of importance is, as you are programming, think of Industrial 4.0. Do not program something that will be obsolete in 5 years to come. So as you have asked Stephen Gitahi, thank you for that question. It's an advice even I would give to us as we are programming, as we are learning about programming, always have in mind whatever you are doing, how will it be incorporated in 4.0? I don't think there is, I hope I've answered your question. All right, so the next thing that I'd like us to handle, I wanted us to have at least one family that we can look at. And I chose to use the Siemens Simatic family. And the reason is because it is one of the most commonly used in industries around Kenya and around the world. They are all over. And they are grouped into 5, as you can see there. We have basic controllers, we have advanced controllers, we have distributed controllers, we have software controllers and drive controller. Drive controller actually is fairly new to the system, and I will explain once we get to it. So the basic controller, you can think of it like your compact PLC. The advanced controller, you can think of it like your distributed PLC, your modular PLC. All this I will explain in the next few slides. This is your basic controller, and I have given you examples. I am sure you have seen all this somewhere. If you have not seen, at least you can see. So we have the basic, which is a logo, Siemens logo, and it usually has 8 inputs and 4 outputs. It can be programmed using the screen that you can see right there, or using a programming cable connected to it. We also have a 7200 and a 7200 Smart. I have not been able to put the picture of the same there. And this S7200 Smart is actually a new technology that has come up also. Mr. Stephen, as you were asking about Industrial Smart, Industrial 4.0, S7200 have advanced in that, and they have produced 200 PLC, which can do much more than the basic 200 that was there. It can now be able to communicate via Ethernet. If you discovered before, 200 was not able to do the Ethernet communication protocol. So we also have a 71200. This is actually also an advancement from 200 to 1200, can host much more inputs. But as you can see from the photos there, they are all compact PLCs. One thing that arises from it is the fact that compact PLCs do not have to be compact. They can be added modules to it and programmed to be able to act like a modular PLC, as you can see from the 1200, S7 1200 that I have listed there. So that is the basic controller. We have the advanced controller, and this is what is most commonly there now in industries. There are 3 there that I've listed. There is the S7 300, the S7 400, and the S7 1500. From your photo there, The one that is on the top left is the S7-1500. The one that is on the top right is the S7-300, and down below is your basic S7-400. As you can see, they are modular. So there is a module for each. And looking at the things that we highlighted as we started, the parts of a PLC, we said that we have a CPU, we have a power supply, we have a digital input, we can have a digital output, we can have an analog input, analog output, communication protocol. We can have all those things to form a modular kind of PLC, which we call an advanced controller. So the advanced controller communication protocol is usually either Profibus or Ethernet or Profinet or even Fieldbus, as we shall see in the next few slides. Then we have what we call a distributed controller, as you can see on your screen right there. So imagine you have your basic PLC at point A, but you have your actuators and your sensors many kilometers away. So for example, in an oil industry, you have sensors that are thousands of kilometers down, but your basic controller is near the ground. So how do you program it so that you can have those sensors to be able to communicate to the PLC? It might not be logical to have sensor cables connecting from down all the way up. So what they use is called a distributed controller. And Siemens have their own that they call Simatic ET200SP or ET200 Pro that they use. So what happens is from the sensor, it connects to this ET200SP, either through the signal cables that you're seeing there, the blue, the green cables. And then from this, a cable can run either using Profinet. I'll show you in a few those kinds of cables, either using Profinet or using Profibus. And all this run up to the main CPU. And then now the CPU can be, the one that is hosting the program can be able to interpret what it is needed to be done and actuate an output. So these ones are the distributed controllers. Then there is a software controller. This is also an advancement that is coming up that you will not also need. They are used whenever maximum precision and speed is required, as well as PC-based automation. You have heard of things that we call PC systems. And I'll show you in the program that is just about next, that there are programs that cannot be achieved by a basic CPU alone. And you will need to incorporate a specific software that controls different softwares and connects to them. So this is a software control, and I've given you examples there that the 1500, for example, has two that they are called software controllers, Simatic ODK 1500S. I am sure you can see it from your screen. And I have given a reason as to why they are used. And I've said it's because they are used whenever maximum precision and speed are required. And the last one is the drive controller. This is also a new series, and it is a combination of controller with motion control and drive control in a single device. For those who work in industries, maybe you have seen there are different drives, there are different PLCs, but imagine a PLC that is both a drive and a PLC at the same time. This is what we are calling a drive controller. So Siemens have been able to come up with this series, I think 2 months ago, that combines motion control and drive control in a single device. So we can now look at the communication protocols. And I'm sure you've seen all these kinds of cables somewhere. If you have not, they are right there. So Siemens use these kinds of cables to communicate. The first one being an MPI cable. For those that don't know the meaning, it's a multi-point interface cable. There is also a PPI cable, there is a Profibus cable, there is a Profinet cable. So from your picture right there, there is a PPI cable. A PPI cable is used to program a Step 7 200 machine, CPU. And the difference between a PPI and an MPI is actually the termination point of an MPI is one side RS-232, the other side USB. But as you can see from the PPI, both sides are RS-232. For the Profibus cable is the purple one that you are seeing on the diagram there. And these ones are used for rugged applications. You remember the example I gave you a few minutes ago, as I was telling you about an oil industry. So what happens is they might use a Profibus or a Profinet cable to run from down there all the way to the CPU. So the Profibus and the Profinet are shown on the diagram. The Profinet is the green one, and the Profibus is the purple one. The difference between a Profinet and Ethernet cable is simply the bandwidth. The Profinet cable can handle much more bandwidth at faster speeds than the normal Cat5 or Cat6 or your, as you call it, Ethernet cable. So let's now look at the software. It's the last subtopic that we are looking at. So there are different kinds of softwares for the Siemens series. We have our Logosoft, we have MicroWin, we have Semantic Manager, we have CMIT software, we have TIA Portal. These are the basic, the 5 majorly used softwares by Siemens. I'm sure most of you have encountered one or more as you are about your work. So this is an example of the first one, is a Logosoft. It is used to program Siemens logos. So let me show you, I showed you a while back an example of a PLC logo, and it is this on the top of your screen, a small compact logo. So the software that is used to program that is called Logosoft software. I hope you understand. Then, so that is Logosoft, that is how it looks like. Today we do not have time to go through the functioning and the structuring of the PLC programming, but as you can see, there are inputs. If I can just remind you, we talked about functional block diagrams. So this is an example of an FBD, functional block diagram. There is an on-off, there is a Boolean somewhere, there are statuses. All this you can program using the Logosoft software. The other one is software called MicroWin. And as you can see down there, it says that it is used to program S7200 PLCs, the compact PLCs that I showed you as we were beginning. So this is how it looks like when you open it. We also might not have time to go through it today, but this is how it looks like. If somebody asks you what software is used to program a 7200, it's a MicroWin. Okay, then the next one is the one that most of us know about. It's called the Semantic Manager. And this is how it looks like from a distance. As you can see, this one has been programmed using ladder diagrams. And from here, you can be able to change the programming language from ladder to any other thing. That is the advantage of using a Siemens a program. So in later classes, in the next class, we'll actually be working more with this software. We'll be knowing how to program different inputs, different logics, how to come up with different systems to be able to actuate units in a company, in an industry, to be able to show what can be done using the Siemens PLCs. So that is your Semantic Manager. There is also a software called CMIT. This one is used to program process systems. If you've had something called PCS7, that is a process system S7, Semantic 7. So it is a system, it's like a SCADA for the PLCs. I will not explain much about it because we'll be covering also much more of this in the next class. And the one that we also know about it is the TIA Portal. This is an advancement. And the thing about TIA Portal is that it has incorporated all the softwares that we have named above into one system. So for the one that was asking about Industry 4.0, if right now you can check the Siemens website portal, they have come up with a version, TIA Portal version 16, that can be able to connect and can be able to actuate Industry 4.0. So that is what, those are the kinds of softwares that we are using. So at this juncture, I'd like to answer any of your questions that you have. before we close. So thank you guys.
What is the main difference between the DCSs and SCADA in relation to the use of PLCs?
Okay, so I'd like to answer you, Mr. Peter Mose. It's a good question. So first of all, let me explain to you what each one means. A DCS is a distributed control system. A SCADA stands for supervisory control and data acquisition. So in relation to the use of PLCs, first of all, I want you to have an understanding that PLCs form the basis of both. You cannot have a DCS without a PLC. You can also not have a SCADA without a PLC. A SCADA, if I can break it down, and we'll also be doing more of this in the next classes, a SCADA, there is a supervision part, which, as we'll talk about it, you have seen it in industries, is what we call HMIs. Yeah, you have seen HMIs in your industry. So that is for the S. The C, the control, is now your PLC. The control is your PLC. And then there is data acquisition. Data acquisition now is the sensors, the sensor technology, the encoders, the proximity sensors, all those things. So the PLC forms a basis that if you have to communicate between one PLC and another, then you'll have to incorporate, if you want to be able to control and to monitor how PLCs are working from one system to the other, then you'll have to incorporate the system called a SCADA. A DCS system, on the other hand, is also like a SCADA system. The only difference between a DCS and a SCADA system is that the distributed control system might not necessarily have a monitoring, the supervisory part that SCADA has. So if a PLC between machine A, if it is a labeling machine, is communicating between a labeling machine and a filling machine, then we might not need to have a monitoring device between the two. But if we need to have a monitoring device between the two, then we'll have to incorporate the SCADA that is required, as you have seen there. So I hope I have answered you, Mr. Peter Mose. Yeah.
Okay, thank you, Baraka. Patrick Miner.
Yes.
Yes, you had raised your hand. You have a question. Please go ahead and ask.
Okay, thank you very much. I want to ask a question. When you're making a choice what is the basic requirement or the basic checklist that you're going to do when you want to make a choice on the PLC to use in a specific automating solution or in an automatic in an automation system that you're coming up? Like, what are the basic requirements that you're going to put into consideration when you're making a choice on the PLC to use? That is the question.
Okay, thank you. Baraka, you can take it up.
Okay, that's an interesting question. And the thing is, what you have to consider first, from way back while you were learning, the thing that determines what you'll use, first of all, is the price. And most of the PLCs range from cheap to high, of course. So you have to consider, first of all, the cash that you have in your pocket. If your cash is sufficient, then you should go for the best. There is no specific criteria as to which one is better than which one, but depending on the process that you want to actuate, this is how I'd put it to you, that if you want to go, for example, in a beverage industry, the most common one that is used in a beverage industry is a Siemens PLC. If you want to go, for example, in an industry like a cement industry, the one that is mostly used in a Siemens, in a cement industry is an Omron kind of PLC. So my advice would be, it is not necessarily about what you want to do, but the thing is, if you want to actuate a process, then look at those that have gone ahead of you, what they have done, and do it. The reason we do that is so that it can be easy to configure, it can be easy to troubleshoot, it can be easy for you to have documents and supporting files in case an issue ever occurs. So Mr. Patrick, if you want to use, if you have a system or a project that you want to achieve, first of all, go and research the most commonly used PLC at that time, and that one will help you make a decision. Of course, you can reinvent your own wheel if you want to, but it might be harder and might take more time than usual. Thank you.
Thank you very much.
Okay, thank you, Baraka. There is another question on the chat. I think probably you've seen it. What is the name of PLC used in a BTS? And is it different from the PLC we are currently learning?
Okay. I believe by BTS, you are talking about building technology systems. I hope that is what you are talking about, Mr. Simeon. So if it is a BTS, what I will tell you is, first of all, like the way I've told Mr. Patrick Maina, that there are specific PLCs and systems that have come up with, that have been able to come up with a controller for specifically for building and automation systems. So while the normal Siemens PLCs is used for industrial setup and for production and for food and beverage industry, there is what we call BAS, building automation system, which is also a controller that can be used now specifically for that building automation system. It does not mean that these others cannot be used. What it means is that it is the best suited for your building systems. Yeah. So if you are using a building automation system, it has its own controller, it has its own inputs and outputs, it has its own programming techniques, you see, but it does not differ much in terms of programming, does not differ much. All that differs about is the naming, how to configure it, and all that. If you're interested, we can have a class when we are talking about building and automation systems that can be able to help you achieve the intent that you have in mind. Thank you.
Do we use this kind of PLCs for protection? I don't know if that question is clear, but you can pick it up.
Okay, I think what you mean is if there are specific PLCs that are configured that to carry out protection. And I would like to tell you that yes, there are. So what happens is, the first thing for any manufacturer, they have to protect their PLC. So if they do not have an internal mode of protection in the PLC, then they will get you a safety device that you need to configure to the PLC to make sure that it is protected. So there are different protection techniques. And one of the things that are used in sensoring technology, you have heard of ASI, actuator sensor interface. They have safety protection devices. When you are talking about protection and when you're talking about automation, as somebody asked previously, and when you're talking also about Industry 4.0, building block of Industry 4.0 right now is security systems. So if you can achieve security and if you're programming anything, you have to have security in place. So all these manufacturers have been able to come up with their own systems of protection. So it is up to you to know which PLC you are using, and then I can advise you on the protection mechanism for it. I hope I have answered you, Mr. Peter. Hi, this is from Ed. Would you consider incorporating discussion of safety of PLC SCADA DCS in relation to security, cybersecurity, as we have witnessed with recent attacks on production? Yes, sure. That is actually something we are putting in the pipeline to come up with. It's a course we are trying to structure on how we can educate our clients on how to protect their industrial systems to ensure that in case of a cyber attack, there will be no loss of information, there will be no mischievous activity. So it is a class also that we will send invites to you that you can be able to tune in and have the knowledge of. As we are talking about Industry 4.0, one of the greatest things and the greatest attacks is actually in regards to cybersecurity. And that is something that has been covered in detail by each and every manufacturer. So we have to make sure that each and every system, the whole essence of an automation system is efficiency. So if there is efficiency, but there is no safety, then in the first place, it is not even efficient anymore. So you have to know, yeah? So you have to know what security system you are using. Okay. Bernard Muteti is asking, hi, please consider industrial communication as an area of discussion going forward. It is also in our unit of class. As I have told you before, this was the basic class. So as we are building up to it, there are so many other things that we learn. We learn about programming, we learn about industrial communication. We'll also learn about SCADA systems. We learn about driving technology, drives. We learn about pneumatics and hydraulics. I'm sure there are people that are well versed to cover all these topics. We have a well-able team to do all these things. So we have only learned the basics today. So from today also, we'll be building up to what we have learned. As you have seen, it is purely theoretical today, but as we are building up to it, you will get to have an understanding of how all these protocols, they connect in terms of communication. Thank you, Bernard. The final thing that I would like us to know is that, as you have all seen, this was just a basic theory class. And I would like to invite you guys for the next class, where now, having gained the knowledge and having gained the theoretical knowledge that I have given to you, that is all that there is. You can find even much more information on the internet and all. But now, the next classes, I would like to invite you so that you can be able now to do programming of the same. So from the next classes, what we'll be doing is we will be programming different kinds of PLCs with different kinds of languages, and we'll be able to achieve simple processes as we build up to complex processes. By the end of this series, I desire us to have come up with a basic industrial setup kind of problem and solved it using PLC programming. So I'd like to invite you for the next class. We'll be using different softwares as highlighted in the slide. And I want to thank you also all for tuning in and for listening. Thank you. Thank you.
Okay, thank you, Baraka. To all the participants, thank you so much for taking time to be part of this session. Like Baraka has mentioned, that this was just a basic introduction of PLCs to set us up for the next 4 sessions that we are going to go in depth on programming. So we welcome you to join us in our next series of webinars, which will be beginning again next week. So we will have the first module for programming on the 17th. The second one will be on the 18th. The third one will be on the 24th. And the fourth one will be on the 25th. So we're looking forward to you being part of the journey as we perfect our skills, knowledge, and capability around PLC programming. The other thing we will do is, upon your registration for this, the subsequent webinars, then we should be able to engage you to install the softwares that we will be using for the programming sessions. So you kindly requested that when you receive the invitation, please sign up earlier enough so that the facilitator, who is Baraka, can engage you to install the program in your computer for the next sessions. So we will send you an invitation on mail with a schedule, the calendar of activities for the remainder 4 sessions. And we hope that by the end of it, you will have found your time and investment valuable. Baraka, thank you so much for taking your time to share today on the introduction of PLCs. And we look forward to you giving much more to the participants in the subsequent webinars as well. So ladies and gentlemen, I beg to bring this to a close and look forward to engaging you in the subsequent webinars that we will be running again within this month of June. So be on the lookout for the communication on the webinars that are coming up as a follow-up to the introduction of PLCs, and we will concentrate on PLC programming. Stay safe, keep on sanitizing and washing your hands, and Stay in great health. Bye-bye.